This is Algebra 2, day 1 of our workshop. We're going to begin by talking about what is a real number. What is a real number? That is so fundamental. What makes up our real number system? There's actually only one that is not real.
Infinity?
Infinity is not a number, it is a concept. Actually, the only one that is not real, which we will deal with this year, is the imaginary number. And I equals the square root of -1. Doesn't work if you put it in your calculator. It's the only number that's not real. The real number system is made up of irrational numbers. What makes a number irrational? Anybody? What makes a number irrational?
Okay.
Yeah, everyone should have this calculator. Not a graphing, but save it for next year because we will. But I don't allow graphing calculators in this class. Irrational numbers. What makes a number irrational? Anybody know? It has unending decimal places. Unending, non-repeat, I should add, non-repeat decimal places. So pi. Pi is irrational because it has decimal places that are unending and they do not repeat. Now, isn't it amazing that with the technology that is available to us today that we cannot say what is the very last decimal of the number pi? Isn't that crazy? Okay, I really do think that is crazy, that our technology, because, you know, this concept is bigger than anything man can create. The square root of 2 is an irrational number. Anything that has unending, non-repeat decimal places, you cannot get to the last decimal place, is an irrational number. All right, so if that's irrational, then what makes a number rational? All right, so those of you that have had me for geometry, you know that I am big on terminology. All right? Big on terminology. So, what makes a number irrational? I mean rational. We're talking about rational now. I can write it as a ratio. So, 1/3. 0.123. Can I write that as a ratio? Just read that number to me. That's 123. What? Thousandths. 123 thousandths. So it's a terminating decimal. They are always rational numbers. Terminating decimals. Anything written as a ratio. There's one more. Repeat decimals. Anytime we have repeat decimals, we can always write those as a ratio. What is 0.3 repeating as a ratio? Y'all know that one? 1/3. It's 1/3. Every number that has a repeat decimal in it can be written as a ratio. We'll actually have a whole lesson on that this year. So some numbers are irrational. some numbers are rational, and then we have, I'm going to use the word integers. What are the integers? They're really known as whole numbers, but most textbooks use the word integer. That's all negative numbers, 0, and positive whole numbers. So dot, 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 -3, -2, -1, 0, 1, 2, 3, on and on. The only one below that is counting numbers. It goes from 1, 2, 3. When you count, you don't start in a negative. You just start 1, 2, 3. All right? These terms are important. You have a question that asks you something about integers. You need to know what an integer is. If you have a question that says solve for the real solutions, it's saying don't look at imaginary solutions. Got it? It's saying only look at your real solutions. Now, in math, we have a very specific order of operations. What is the order of operations for math? Does anybody know? Remember, yes?
PEMDAS.
PEMDAS. All right. What is PEMDAS? The P stands for
Parentheses.
E,
Exponents.
M,
Multiplication.
D,
Division.
A,
Addition.
S. What's the order that we do those in? What's first?
Parentheses.
What's second?
Exponents.
What's third?
Multiplication.
Not correct. Third is multiplication and division together, left to right. We do multiplication and division together, left to right. So, if I don't multiply then divide, I do multiplication and division left to right. Got it? So we do take care of parentheses first. We do exponents second. Third, we do multiplication and division left to right. Then, so multiplication and division left to right matters. Addition and subtraction is the same rule. We do it together, but it doesn't matter. The order for that is not so specific. Because if I can do 5 minus 4, 5 minus 1, which is 4, plus 3 is 7, right? Or I could do addition first, 5 plus 3, 8 minus 1, 7, and get the same answer. Here's where people make their mistakes. This is multiplication and division together, left to right, okay? All right. So we're going to look on page 1 and make sure we can get our order of operations correct. All right, so numbers 1 and 2 look different from the rest. Can somebody tell me what is different with numbers 1 and 2? As compared to all of the other.
We have exponents.
Okay.
At least two of those.
Okay. 2 has exponents. What else is different?
We have unknown numbers.
They have what?
Unknown numbers.
Unknown. What do we call unknown numbers?
Variables.
Variables. Okay, they have variables. What else is different? Something else pretty. What?
It's an equation.
What were you saying?
They have something on both sides of the equation.
Yes. Numbers 1 and 2 are equations. And the rest are called what? Do you know? They're expressions. The rules on how we handle equations versus expressions are different. An equation has an equal sign. An expression has no equal sign. If I have an equation, this is going to be the rule in Algebra 2. If we have an equal sign, we're going to eliminate the denominator. If we have fractions, we're eliminating the denominator because we're going to use rules that we can use for equations that cannot be used for expressions. If we have no equal sign, we're going to go to a common denominator. So why is this the case? Why do we treat expressions different than equations? Because the rules of algebra say if I have an expression, the only operation I can do is multiply any number by 1. That's all I can do. I can only multiply a term by 1. Now, what's xy over xy?
1.
That's 1. So our 1 is going to look different. It's going to look like 6 over 6 or xy over xy or x over x. It's going to look different. But anything over itself is 1. So if I have an expression, then I'm going to make a common denominator. If I have an equation, I'm going to eliminate the denominator because if I have an equation, I can add or subtract a value from each side of the equal sign. Like, if I have 6 plus 4 is 10, we know that's a true statement, right? I can add 20 to each side, and it remains a true statement. Do you agree? Or I could subtract 5 from both sides, and it remains a true statement. That also applies with things that look like this. I can add any number to both sides, and I don't change the equality. I can add 10 to both sides. I can subtract 3 from both sides without changing the equality. Make sense? All right, so in Algebra 2, the rules have not changed, but the problems are going to look more complex. But if we can lock in the rules this year, we'll do so much better when we get to pre-calculus. Okay? So, add and subtract a value from both sides. I can also multiply or divide every term by the same value. So that would be like if I have 2x squared over 3 plus 6x over 2 equals 10. I have an equal sign. What's my rule? Do I have denominators? I'm going to eliminate them. So I'm going to eliminate them by multiplying every term by the same value. And that value is going to be the least common multiple of your denominators. So what's the least common multiple of 3 and 2? 6. So I'm going to multiply every term by the same value. every term. And here's Miss Haleyism. Okay, the first Miss Haleyism, which we've not got any on my board, but you're going to learn them this year. So, equal sign, eliminate denominator. No equal sign, common denominator. That's a Miss Haleyism. Now, when we multiply, this is another Miss Haleyism. Before you multiply, we simplify, but we can only simplify terms that are multiplied. So before we multiply, we simplify, but we can only simplify terms that are multiplied. So we're going to simplify the 6 and the 3. That becomes a 2. Got it? We're going to simplify the 6 and the 2, and that becomes a 3. And then we'll multiply. 2 times 2x squared is what?
4x squared.
4x squared. 3 times 6x is? 10 times 6? 60. Got it? That's how we're going to eliminate the denominators. By multiplying by a number. Now, can I look at this and simplify that equation at all?
Yeah.
I can. How can I simplify?
Yeah, with that far ahead, you could divide by 2.
Every term is divisible by 2. That's correct. That's the other one. I can divide every term by the same value. And simplify. So it becomes 2x squared plus 9x equals 30. That is a rule we can use. Make sense? We're going to use those rules this year. All right? So, it's important that you understand. An equation has an equal sign, eliminate denominator. An expression has no equal sign. We are always going to a common denominator. That rule doesn't change no matter how difficult the equation or expression looks. All right? So, let's look at order of operations page. Order of operations. And we'll look at number 1 first. My goal is to get through page 7. Okay, maybe we'll make it. I don't know. All right. So we have to follow order of operations. The first thing we should do here is what? What's the first thing? The P in PEMDAS. What is that? Parentheses. I have 2 parentheses. Let's just look at this one. How do I eliminate the first parentheses?
Multiply.
Distribution. That is correct. I distribute the 15 to both of the terms. It eliminates the parentheses. What is 4 15ths? 4 15ths. That's right. You know how I do that? I do 2 15ths is 30. 30 times 2 is 60. Make sense? The negative stays because it's 15 times 5. Now I just have to add one more 15 to 60.
Some negatives.
75. All right, I have this parentheses, so I'm going to distribute 16 to both of the numbers, and that eliminates the parentheses.
64.
16 times 4 is 64. Now I need 2 more 16s.
96.
So that's 96. All right, now I want to solve this. So I'm still going to use the rules for an equation. But I'm going to simplify on both sides first. I have no terms that are like terms. What does the word like term mean? What are like terms? They are terms that have the exact same variables raised to the same, I almost want to write exact again, same exponents. So, are those like terms? Are these two terms like? They are not. Both x's are not raised to the same exponents. Got it? These are not like terms. If, I'll change this one. Are these like terms? These are like terms. Exact same variables raised to the exact same exponents. What are these numbers out front called? Starts with a C. Well, this is a constant. That's a number by itself. Coefficient, yes, the other C word. They're coefficients. So when we have like terms, we can combine their coefficients. Okay? So 6 minus 2, that would be 4x squared y cubed. The exponents don't change when we combine like terms. Got it? We're not adding and subtracting exponents. We're adding and subtracting the coefficients. Okay, so we can do that. We do have like terms, but they're on opposite sides of the equal sign. So we have to use addition and subtraction to move them to the same side. Did y'all notice I have a new board? I have a new board. I can use the whole board. Like the whole board. I'm so excited. Okay. Nefeli, I have a new board. Wait, you just have to see the whole thing. You see? All the way. It's beautiful. Okay. I'm videoing for Nefeli. Okay. Now, nothing on the left I can simplify, so we're going to leave the left alone. But I can combine the constants on the right. So 64 and 10, 74. All right, so we want B equals, right? Do you want to move the constant to the left or the right? Where do you want to move the constants? Where do you want to move the B? And does it matter?
No.
Doesn't matter. Okay, so what's your preference? Yes.
I would like to.
Wait, let me think of your name. Dag nabbit. I gotta learn your names. John. Okay, John.
I like to keep the variable positive. So
I
would
do
be
too.
So I would be moving the variable to the left side of the equation.
Yes, I would too. So we're gonna add 96B to both sides. Because remember, when we're adding and subtracting, we just have to do the same number on both sides of the. When we're multiplying or dividing, how's that different? We have to multiply and divide every term by that value. Adding and subtracting is just on both sides. And I'm going to do this in one fell swoop. I'm going to cross that out. I'm going to move the 60 to the right. Now, I'm going to keep my equal sign in the middle. 96 minus 75 is what?
21.
21b. 74 minus 60.
14.
Okay, now I want to solve for b. So now what operation am I using? And I have to divide every term by the same number. Do y'all see the rules being applied? So simplify that. What is it?
2/3.
2/3. B is 2/3. Okay, the rules stay the same. The problems look harder. But if you can lock these rules in your mind, I promise you the rules are not going to change. The problems just get harder. Okay. Let's work number 2 together. And we'll do 3 and 4, and then I'll let y'all do the rest. I am having to use this spray every time. I got to figure this out. And this eraser, I'm not going to be able to use my old erasers. Maybe I need to order whiteboard erasers. I don't love whiteboard erasers. I don't know. Okay, let's do number 2 together. All right, what's the first thing we're going to do? Distribute. And by distributing, we eliminate the parentheses. So we have negative 6x minus 9. Okay, what am I going to do here?
You're going to distribute the negatives.
Absolutely. That negative is distributed to both terms. So it becomes positive 3x, positive 5. Right here is where you're going to make a mistake. Do you know how I know this?
Has this happened before?
I've taught this way too long. Exactly. Yeah. This is where students make mistakes. So if you can lock this in your brain now, I will be so tickled pink. Okay. All right. Now what's my next step? Exponents. What is the difference? We're going to get to exponent rules Wednesday. What is the difference between this? This is what's here. Yes.
One's
Drew,
positive.
right?
Yes, ma'am.
Okay.
One's positive, one's negative.
Which one's positive?
The top one.
The top one's positive. That's negative 2 times negative 2. That's positive 4. That's the opposite of 2 squared. Okay, so this is going to be a negative. So it's negative 6x minus 9 minus 4 equals 3x plus, let's combine our constants. 5 minus 2 is 3. Now let's combine our constants on this side. Negative 9 and negative 4 is?
Negative
No, negative 9 and negative 4? Negative what? 13. Okay, you still want to move your variables to the left? What's your preference? Variable to the left or right?
You're right, just
To the right. Let's go to the right. So we're going to do the opposite, or inverse, it's really the opposite operation. We're going to add 6x to both sides and subtract 3 from both sides. Our equal sign stays in the middle. Negative 13 minus 3 is negative 16. 6 and 3 is 9. Now we're going to use the rule of division, but we have to divide every term by the same value. So x is negative 16 ninths. in your upper levels, we would all, if a number can be written in a fraction, 100% of the time you write it in a fraction. We would never write a value in decimal form that can be written as a fraction. And I'm sure those of you that had me last year, we don't use mixed numbers like 3.5. We would write that as 7/2. So we use improper fractions when we can. That is exact. If you write it in decimal form, that is an estimate. Okay, so I want y'all to work 3 through 11. And let's see how fast do y'all think y'all can work these? I'm videoing, so. Okay, I'm going fast. You think you're working fast? No. How about we work the odd ones? No. Yeah, let's work the odd ones. 3, 5, 7, 9, and 11. 3, 5, 7, 9, 11. That's 5 problems. Go.
-2.
It's just positive 1. You see that? Negative 2 minus 3 plus 6. All right, minus, what's negative 5 times negative 2? 10. What's inside those parentheses? Negative 2 minus 4?
-6.
Negative 6 times 3?
-18.
So it's plus negative 18. So it's negative 3 times 1? That's negative 3 minus, what is 10? There's nothing on the outside. 10 minus 18?
-8.
Negative 8. 2 negatives make a positive, so what does that equal?
5.
Positive 5. Get 5? I hope you got 5. All right, number 5 has a negative 3 on the outside. What did you get in these first parentheses? Brackets. What did you get in this first bracket here?
-13.
Well, it would have been negative 2 times negative 2, because negative 1 minus 1 is negative 2. Y'all following me? So that would have been 4. Negative 1 plus 4 is 3. So you should have gotten 3 inside those parentheses. What'd you get inside the last parentheses?
5.
It is 5. So negative 3 times negative 2 is positive 6. 6 minus 1 is 5. So what does that equal? Negative 45? Negative 45. Make sense?
Yes, ma'am.
All right. Let's look at number 7. Number 7, the first term is negative 5 minus negative 2, which is negative 5 plus negative 2, which is what? Negative 5 plus 2. 3. 3 plus 8.
Wait, it's a negative 3.
It's negative 3.
Negative 3. Negative 3. Yes, thank you. Negative 3 plus 8.
5.
5. And now it's 5 minus what? 20, right? 5 minus 20 is?
Negative 15.
Negative 15 minus 3?
Negative 18.
Negative 18. So you got negative 18 in the numerator. Then it's 6 minus, but we have to multiply. What's a negative 4 times negative 3?
12.
12. That's a positive 12. 6 plus 12.
18.
So number 7 is negative 1. Are y'all following?
Yes, ma'am.
All right, now we have negative 2 on the outside. Let's figure out what's inside these 2 parentheses. All right, so in this second parentheses, we have to first do negative 2 minus 2. That's what? Negative 2 minus 2 is negative 4 times negative 3,
12.
positive 12, but we have to add to positive 12 negative 2.
10.
10. Did y'all get that? All right, last one. And last parentheses, brackets. Negative 2 times negative 4 is what?
8.
8 minus 3.
5.
That's negative 10 times 10. That's negative 100, right? How are we doing? Order of operations is key to algebra. All right, the last one. Let's multiply the first 2. 6 times negative 3.
Negative 18.
All right, let's go inside the brackets. I'm going to move the negative 3 to the front. Did y'all see that? I'm moving the 3 to the front. It becomes negative. 5 minus 4 is 1. 6 minus 2 is 3. You see how I did that? Does it matter if I multiply 1 times 3 times negative times 3 or negative 3 times 1 times 3? That's called the commutative property of multiplication. So 3 times 1 times 3 is the same thing as 3 times 3 times 1 is the same thing as 1 times 3 times 3. Got it? So I moved that 3 in the back to the front. Do y'all see what I did? So this is negative 18 times negative 9. That's a big number. What is that? Y'all, what is it?
That's 260.
Wait. Number 9. No, did I jump?
It's 4. It's supposed to be 4 in the last. It's not 3. It's 6 minus 2 is 4.
Are we on number 11? See, I jumped up to number 9. Never mind. I did. I jumped up to number 9. All right. So that's negative 18, negative 3. This should be 4. That is correct. I jumped up to number 9. My eyes moved. Thank you. That's 4. That's negative 12. Okay, what is that big number?
260.
216.
No, 16.
216. All right. Order of operations is key. Most of the time, students just get the multiplication and division wrong. It's together, left to right. All right, let's move to evaluating expressions. Remember what I told you about expressions? What did I tell you about expressions? Expressions, what do you know about them now? Okay, ladies and gentlemen. Just regurgitate what I said. What did I say about expressions? What's an expression?
They don't have equal signs.
No equal sign. What are the rules? Common denominator. And what operations can I perform? Only one. What's the only operation I can perform?
Multiply anything by 1.
Yes, thank you. Multiply by what is equal to 1. Here we're going to substitute. We're going to do lots of substitution in algebra. Our substitution might look a little different from this. This is very elementary substitution, but it's important concept. So we can, let's look at number 1 together. Value of n squared minus m. N squared minus m. And I tell you the value of n is 8, and the value of m is 7. I can use substitution. Substitution says, I know the value of n is 8, so I can substitute 8 in for n. So it becomes 8 squared. M is going to be 7. I can substitute 7 where m is in the expression. And then I can calculate it, what the value is. 8 squared is?
64.
Minus 7 is?
57.
Now, what if I told you the value of n is negative 8 and the value of m is negative 7? Would that change the value of the expression?
Yes.
All right. So, n is negative 8 squared. What's negative 8 squared?
64.
It is 64. But now it's minus a negative 7, which is plus
71.
7. So it's 71. All right, let's go around the room. We're going to work these. All right, Aaron, I want you to look at number 2. What is 8 times x minus y?
Wait, where are we looking at?
Number 2. Yeah.
On the examples?
No, on back of page 1. Go back to page 1 and look at the back. There we go. It's on the back of page 1, number 2.
8 times 5 is 40. And 8 times negative 2 is negative 16.
So what's the answer? I did it different, but I knew the answer. Did you do it different?
Yes, ma'am.
Thank you.
24.
It is 24. Here's what I did. I did 8 times 3, which is 5 minus 2. Everybody see that? All right, John, number 3. It is 7. Everybody with me? 4, Seth.
4 divided by 8 is 2. 5 minus 2 is 3.
Yep, that's it. Ella, number 5. Huh? You can say the answer. 11 is correct. Okay. Now I have to remember. Lily Gaspard with 2 L's. I have a Lily that has 1 L, but you're 2 L's. I'm going to try to do my best to remember this. Okay. Number 6. What is number 6? 20. 1 cubed is 1. What's the cube root of 1? It's 1. What's the 5th root of 1? It's 1. What's 1 to the 5th power? It's 1. What's 1 to the 0 power? That was the trick, wasn't it? It's still 1. What's 1 to the negative 5th power? It's still 1. Okay. You ready, Ben? Number 7. Oh my goodness. That's big math.
128.
Say that again.
128.
Does anybody get 128? Yes. We're going with it. 8. Drew.
12.
Is 8 12? Does anybody agree? Yes, I agree. 8 is 12. Everybody got it? Madeline, you ready for number 9? Oh, wait, you want what? Oh, 11. I thought you were saying, do you want me to work problem 11? Is it 11? Let me look. Is it 11? 28 minus 17? Yes, it is. Sam, number 10. Say that again. 2, yes, I heard 10. Excellent. Rain, number 11. I don't really like this answer. Well, yes. Wait, that's 1 and 5. Okay, you have to do 2 divided by 2 first for number 11. Got it? So 2 divided by 2 is 1. So 10 minus 5 plus 1. 6. Okay. Leah, number 12. That's 28. 7 minus 2 is 5, and 28 is, what'd you say, 30? Yes, that's correct. Okay, let's go to page 3. Simplifying expressions. That's combined. We're going to go back through the room. Got it? We're just going to keep going. All right, so you're just going to combine like terms. That's all we're doing, combining like terms. All right, Peyton, you're combining like terms. All right, so what's number 1? 15x plus 3y. Yes, got it? Lock, number 2.
10x squared plus 8x plus 5x plus 3y.
Yes, correct. Everybody following? Aaron, 3.
11y plus 5x.
Correct. 4, John.
12y squared plus 10y.
Correct. Seth, 5.
6x plus y.
Exactly. Ella, number 6.
8x squared plus 4y.
Okay, it's one more. It's 9x squared because that x squared on the very beginning is a 1 coefficient. Got it? All right, Lily, 17.
Wait.
Exactly, that's what I said. 7. The first number is 17.
14x minus 2y.
It is 14x, but it's going to be plus 2y because it's positive 3 minus 1. You see that?
Yeah.
All right, Madeline, 8.
2y squared plus 4y plus 2x.
Yes. 2y squared plus 4y plus 2x squared. All right, number 9, Sam.
16x plus 4y.
Yes. And Drew, number 10.
19x squared root of 5 plus 3y.
All right. Did you say plus x?
No.
X, it's got to be a plus an x. Okay. Multiplying polynomials. What is multiplying polynomials? How are multiplying polynomials related? How is, rather, multiplying polynomials related to factoring? What is a polynomial? It means many terms. Oh, is that what you were going to say, John? I bet that's what you were going to say. All right, I'm only going to write with the colored markers. The black ones I'm struggling to erase. All right, so if I had are these polynomials at all related?
Yes, ma'am.
They are. If I go from here to here, that's called factoring. Factoring is like division. I've taken every term and I've divided by 2x. If I go from here to here, we really call that simplifying, and I multiply. All right? So they are literally the inverse operations. One multiplies, one divides. We're going to do both in the next 15 minutes. We're going to multiply these. These are binomials. And how do I multiply binomials?
FOIL.
FOIL. What does FOIL stand for?
First outer inner last.
First terms, the outer terms multiplied, the inner terms multiplied, and the last. Okay? We're going to do this both ways. We're going to multiply this. I'm going to show you a shortcut, and then we're going to factor this one. So we're going to go both ways. We're going to simplify, and then, okay, so first, outer, inner, last. X times X.
X squared.
X squared, because multiplication of terms is addition to the exponents. That we'll do the outers. X times 3,
3x.
3x. 2 times x,
2x.
2 times 3.
6.
I have like terms. I'm going to combine them. So it's x squared. Like terms is we have an x to the first power. I combine their coefficients 2 plus 3 to make it 5x plus 6. That is called the standard form of what is a trinomial, but it's typically called a quadratic. Quadratic because it's really set equal to y. Okay, that's what makes, the fourth term is y, but it's only when we're solving it. That is in the form of ax squared plus bx plus c. That's standard form for a quadratic. Let's see, it's pretty bad, isn't it? All right, so the A value in this equation is 1. The B value is positive 5. The C value is positive 6. In order to factor a polynomial, you have to have it in standard form. All right, so if I just write another one, what's the A value?
6.
6. What's the B value?
-5.
Negative 5. What's the C value?
10.
10. Okay, it's important to know. All right. Now, we're going to multiply this a little more expeditious. I want you to notice that the first term is the first one's multiplied. The last term is always the last term's multiplied. The middle term is the outers plus the inners. Okay? Well, I'm just going to make up another one. Okay, and we're going to multiply this a little differently. We're going to do the first. The first term is x squared. The last term is
6.
positive 6. Right? This middle term is going to be the outers plus the inners.
7x.
So 6x plus 1x is 7x. Outers plus inners is the middle term. Okay, let's keep going. Let's do the outers plus the inners together, all right? Look at number 2. X plus 6 times x plus 7. What's the, John, you tell me, what's the first term?
X squared.
What's the last term?
42.
What's the middle term?
13.
13x. Do you see that? It's 7x plus 6x is the middle term. Does everybody see that? 7x and 6x is the middle term. So it's x squared plus 13x plus 42. Got it? We're going to do this a little faster. All right, Seth, number 8. What's the first 3? I see an 8. I said 8. What's number 3, the first term?
X squared.
Yeah, what's the last term?
16.
Correct. What's the middle term? Yes. Aaron, 4. First term.
X squared.
Last term.
9.
Middle term. 10x. Are y'all getting this? Rain, number 5. First term. Last term. Middle term. 10x. Got it? All right, Sam, 6. First term.
X squared.
Last term.
Number 6, right?
2 times, yeah, on number 6. 2 times 7.
14.
Yeah, middle term.
9x.
Yes. Madeline, 7. First term.
X squared.
Last.
1.
Middle.
7x.
Yes. Are y'all getting this? The last term is the terms multiplied. The middle term is the terms, is the constants added. Are y'all getting this? Because we're about to go in reverse. We're going to go in reverse, because the last terms are going to be multiplied, the middle terms are going to be added. That's going to be a key on how we factor. All right, Lily, 8. First term.
X squared.
Last,
1.
middle,
2x.
you got it. Ben, 9. First,
X squared.
last,
7x.
no, last term. 3 times 7. 21, middle term.
10x.
10x. You getting this? Leah, number 10. First term.
X squared.
Last term.
7.
Middle. Yes. Okay. Now, we multiplied and we added, right? That's what we're going to do. When we factor, let's look at this one. When we factor, we're looking for factors of A times C. We're multiplying. 1 times 6. Looking for factors of 1 times 6, which is 6. 6. Such that when we add the factors, it equals our B value. So when we add the factors, that's exactly what we were doing when we were multiplying. We added the factors to get to the B number. Okay? So, what are factors of 6 such that we add them and the result is 5? 3 and 2.
-4.
Can't be negative. Has to be 3 times 2 equals 6. And 3 plus 2 equals 5. My first term is always x. This is my second term. That's how we factor. Just the inverse of what we did. Look real quick at page 7. We're going to factor 1. Just so we can, so it's x squared. We'll do 1 and 2. And I'll go back tomorrow. X squared minus 14x minus 15. So we want A times C. What's my A value?
1.
What's my C value?
Negative 15.
1 times negative 15 is,
Negative 15.
we want factors of negative 15. A times C. Factors of A times C. Such that when we add those factors, it equals the B value. What's the B value? Negative 14. So what are factors of negative 15 such that we add them, the result is negative 14? Yes.
Negative 15 positive 1.
Negative 15, positive 1. Negative 15 times 1 is negative 15. Negative 15 plus 1 is negative 14. This gives me my factors. X minus 15, X plus 1. Could I quickly check it? Yes. First term x squared, last term negative 15, middle term is negative 14x. Just what we did. Got it? Let's do 2 real quick. All right, what's my A value? What's my C value?
Negative 10.
What's 1 times negative 10?
Negative 10.
That's what A times C is. So we're looking at factors of A times C such that we add them, the result is B. What's my B value?
3.
Does everybody see 3 as my B value? Okay, I want everybody to think, don't say the answer. What are factors of negative 10 such that we add them and the result is positive 3? Just think, I want everybody to think. Drew knows. Anybody else know? Okay. Okay, good. Anybody else? Multiply, two numbers multiply equal negative 10, but when I add those same two numbers, it equals positive 3. Okay? Okay, good. Good. Lily, what are they?
X plus 5, X minus 2.
So it's 5 and negative 2. X plus 5, X minus 2. Got it? All right, we will stop here today.